The construction process of Ada Prima is an engineering feat in itself. It all started at the giant Mitsubishi shipyard in Japan. This giant ship, consisting of 124 blocks, was assembled piece by piece like a Lego. After the first module was placed on the slipway, cranes lifted the hull into the sky, while the lower decks were shaped by the sparks of welders. Then the superstructures were added, balconies were screwed on, and the huge pool areas were placed inside the shell of the ship. The most striking moment was when this 300-meter monster was first launched into the water. The giant hatches were opened, and everyone in the shipyard held their breath as Ada Prima slowly floated. All these stages were like millions of pieces coming together in a perfect symphony. The result was a floating city, a floating giant. DockMate is a remote-controlled cleaning robot that revolutionizes hull cleaning. With a working height of up to 32 meters and a working width of up to 1,000 millimeters, it delivers impressive performance even on the most difficult surfaces. Thanks to the AquaBlast Plus system, it instantly collects dust, rust, and debris by vacuuming while cleaning the surface with high-pressure water. Thus, it provides dust-free and silent cleaning without harming the environment. With its Caterpillar C 4.4 engine and four-wheel drive system, it offers stable and safe mobility even on uneven ground. The hydraulically driven nozzle system works with 3,000 bar pressure and 94 liters per minute flow, quickly removing old paint and corrosion. ABB Marine stands out with its innovative solutions that are transforming the maritime industry in the field of ship engines and propulsion systems. The Azipod system developed by the company reduces fuel consumption by up to 20% compared to traditional shaft systems, while increasing maneuverability thanks to the electric motor being located outside the ship's hull in a pod that can rotate 360 degrees. This system, which is especially preferred in icebreakers and large passenger ships, enables ships to move more efficiently and agilely. The jumboization process of the Braemar cruise ship was an engineering masterpiece. In 2008, the ship was cut down the middle and a giant 31.2 meter central section was added at the Blohm Plus Voss shipyard in Hamburg. This new section had been previously built by Schickhaus Seebeck Werft in Bremerhaven. The addition increased passenger capacity from 900 to 950 and crew capacity from 300 to 360. In addition, 18 new balconies and a completely renovated restaurant were added to the ship. Around 150 kilometers of new cables were laid and a crew of 300 people were involved in this process. Following this comprehensive 2-month conversion, Braemar resumed its European voyages from Southampton. Built at Navantia's Cartagena shipyard, the S-80 Plus class submarines are a groundbreaking engineering achievement in Spain's naval history. They are entirely Spanish-designed and manufactured, equipped with advanced mission systems and third-generation air-independent propulsion (AIP) technology. The AIP system uses biofuel, bioethanol, to produce hydrogen, which is combined with oxygen to generate electricity in fuel cells. This allows the submarines to operate for weeks without surfacing, minimizing the risk of detection. The first submarine, the S-81 Isaac Peral, entered service in 2023, with subsequent S-82, S-83, and S-84 scheduled for delivery in 2023, 2026, 2028, and 2029, respectively. With this project, Spain joins a limited number of countries that can design and manufacture their own submarines. When the dry docking process begins to clean the ship's exterior, giant water jets and powerful equipment such as steel come into play. When the water is completely drained and the ship is placed on dry ground, the part of the hull that has been underwater for years becomes completely visible, and that's when the real cleaning operation begins. Special high-pressure machines scrape off the algae, mussels, shells, and salt deposits that have stuck to the hull. The water sprayed with tons of pressure even scrapes off old paint and makes the metal surface smooth.
Have you ever wondered how giant ships float on the sea? How do these giant machines stay balanced despite the millions of tons of weight? Today, we will take you to the incredible world of shipbuilding. Believe me, it will be a breathtaking experience to see how these giants are created. The shipbuilding process is not just making a structure out of steel, it is an art of engineering. Have you ever wondered how these giant birds that conquer the skies are made? Today, we will take a closer look at one of the most complex and impressive engineering feats in human history, the airplane manufacturing process. Get ready, because this process is so fascinating that it will get you out of your seat. It all starts with a dream, a faster, safer, lighter airplane, This dream first turns into a detailed plan on paper. Then, a huge factory comes into play to bring this giant machine, consisting of millions of parts, to life. How are the world's steel giants built? How do locomotives manage to glide over rails while carrying tons of load? Today, we're taking you into the fascinating world of modern engineering meets steam and steel. The process of building a locomotive. It all starts in a huge production facility. The heart of the locomotive, the steel chassis, is designed and manufactured down to the smallest detail. Have you ever wondered how the cars you use every day are made? How is such a flawless, powerful, and stylish machine born? Today we will take you behind the scenes of car production. Are you ready to watch this incredible process carried out in vast factories with lasers and robots? Do you know how these huge steel monsters that silently move through the depths of the oceans are built? Today, we will take you to a world full of secrets, the submarine manufacturing process. Get ready, because this process will surprise you. How are these incredible machines that dance in the sky built? Today, we introduce you to the incredible details of helicopter production. Fasten your seatbelts to learn how these flying engineering marvels are born, because a dizzying journey begins. Everything starts with the design phase. The aerodynamic structure of the helicopter is tested by engineers with special simulations. This design turns every molecule of air into an advantage. Then, the production process begins and the fascinating part begins. How are the motorcycles that give you those moments when you feel the wind on your face built? If you're wondering how these two-wheeled engineering marvels are born, you've come to the right place. Today, we're diving into the incredible world of motorcycle manufacturing. Get ready, because the process will amaze you. How are these giant beasts of burden built? How can trucks be so strong, durable, and reliable while carrying tons of weight? Today we take you into the vast and fascinating world of truck manufacturing. It all starts on the giant assembly line in the factory. Have you ever wondered how these incredible machines that glide quickly through the water are made? Today, we take you into the fascinating world of jet ski production. Get ready to learn how these fun and powerful stars of water sports are born. Everything starts with a steel, aluminum, or carbon fiber bar. The first step is the production of the main body of the bike, the frame. The bars are cut to exact measurements with laser cutters and assembled. Then, the heart of the bike, the gear system and chain assembly are made. Finally, the paint and graphics process of the bike is carried out. Bright colors and eye-catching designs complete the bike with both an aesthetic and protective coating. Lobsters taken from the depths of the sea are processed in this giant factory in seconds. Lobsters taken in with automatic conveyor belts first enter the shell-crushing machine that works with high pressure. This machine breaks down hundreds of lobsters per minute with millimetric precision and separates their meat. Then, the meat removal unit equipped with special arms reaches even the smallest pieces inside the lobster and collects them all flawlessly. In the last stage, the vacuum filling line is activated and all the meat is packaged and labeled without any human touch. This system works so fast and impressively that you will not be able to blink while watching it. An incredible journey from giant fish cages to factories, the salmon production and processing process. The salmon raised in fish farms surrounded by giant nets in the open seas are collected by special boats when they reach a certain weight and transported with high-speed water flow systems. When they arrive at the factory, the process begins. The automatic catching machine takes each fish one by one and sends them to the shocking tunnel. Here, the fish, stunned in seconds, are transferred to the cutting unit. Razor-sharp knives process each fish at incredible speed, and the next stage begins, the filleting line. Advanced imaging systems scan the shape of each fish and determine where the robotic arms will cut. Then, the meat passes through the automatic bone remover and is vacuumed by the state-of-the-art packaging unit and is ready for shipment in minutes. Tons of oysters, for one purpose, to separate them perfectly and make them ready to serve. The giant shelled masses that reach the oyster processing factory are first cleaned of mud and stone particles with powerful vibrating separators. Then, the oysters enter the high-pressure washing tunnel and become spotlessly clean in seconds. The most impressive part of the job begins here, the shucking machine. This special machine grasps each oyster one by one, cracks its shell with a delicate knife, and takes out the meat inside at a millimeter angle. Dozens of arms working simultaneously sort hundreds of oysters per minute. Finally, the meat enters the automatic measuring and filling system. It is separated according to its weight and placed in vacuum boxes. This system, which goes from the sea to the plate in the blink of an eye, is like a seafood machine symphony. Tons of shrimp are sorted and packaged in minutes. The giant crates arriving at the shrimp processing plant are first poured onto automatic separation belts. These belts classify the shrimp according to their size and direct them directly to the peeling machine. This is where the real show begins. The system, which works with bladed cylinders and rubber rollers, flawlessly peels the shells of each shrimp, separates the tails, and removes the internal organs. The shrimp are then rapidly cooled in pools of ice water and transferred to the automatic weighing unit. Here, the shrimp, portioned according to their weight, are vacuumed and boxed in seconds by the high-speed packaging machine. These machines work so fast that thousands of shrimp are processed every minute. A true production show. Tons of tuna enter the cans in just a few minutes. The giant blocks of frozen fish arriving at the canned tuna processing plant are first thawed and boiled in huge steam tunnels. Then the fillet separator comes into play. This system automatically scans each fish, separates the flesh from the skeleton with bladed arms, and removes the skin and bones in seconds. The processed meat is transported by carousel to the portioning unit. Here, the fish are weighed according to their weight and filled into metal cans with high-speed filling machines. The liquid filling line comes into play in the final step. After oil or brine is added to the cans, the lids are closed at incredible speed, and all the cans are sterilized in giant autoclave ovens. This giant system turns out hundreds of cans per minute. It is a real storm of fish processing made of steel. The legendary animal of the desert now plays the leading role in milk production with modern machines. The Camel milk production facility operates with an extraordinary system that combines tradition and technology. First, the camels are directed to automatic milking stations, where they are connected to specially designed teat systems. This system draws the milk with millimeter precision with a powerful vacuum pump and transfers it directly to cooling tanks with stainless steel pipes. The milk is then taken to the homogenization and pasteurization line. These machines heat the milk in seconds, purify it from harmful bacteria, and continue the entire process without interruption. At the last stage, the filling machine comes into play. The camel milk is filled into bottles at high speed and is ready to be sent to the shelves with an automatic capping and labeling system. An astonishing journey from the wild plains of Australia to the factories, the kangaroo meat processing process. After being hunted, the kangaroos are first placed in automatic hanging systems. This system transports the carcasses to the slaughter line by conveyor, where high-speed deboning machines come into play. Equipped with bladed cylinders, these machines separate the muscle tissue from the skeleton with millimeter precision. The meat is then taken to the trimming line to be cleaned of fat and sinew. Here, powerful meat separator machines homogenize and classify the meat. The processed parts are sent to an automatic weighing and vacuuming system. The kangaroo meat, separated by weight, is vacuum packed in seconds, labeled, and ready for shipment. This fast-paced production line offers an industrial show of speed, straight from the wild to the table. The silk coming out of tiny caterpillars turns into gold in this factory. The baskets full of cocoons arriving at the silkworm processing factory are first put into giant steam boilers to soften them. This process loosens the outer layer of the cocoon, and now the show begins. The threading machine. The thin tips attached to each cocoon by robotic arms are attached to the spools that rotate every second. These machines can continuously pull kilometers of silk thread from a single cocoon. The threads then enter the drying tunnel where they are dried with perfect tension and wound onto the spools. The processed silk is then sent to the twisting machines. This system combines the different threads to create stronger silk bundles. The whole process proceeds in perfect synchrony, and dozens of cocoons are processed per minute to become pure silk. The elegance of nature comes to life at the speed of the machine. Known for their slowness, snails are processed at the speed of light in this factory. The collected live snails are first taken to the rotary drum separator and cleaned of residues such as mud, stones, and shell fragments. Then, the snails enter the boiling water tunnel, undergo a boiling process of a few seconds, and are directed directly to the shell separating machine. This special machine breaks the spiral shells of the snails with a millimeter rotation and flawlessly removes their inner meat. The meat is separated from the remaining parts in the vibrating screening system and automatically passes to the portioning line. Here, the snail meat, separated according to its weight, is filled into jars or boxes with vacuum filling machines. In the last step, capping and labeling machines come into play. This production line, where dozens of products are prepared per second, reveals the transformation of a slow creature into a high-speed production system. Warning: this content may contain sensitive images, but in the world of industrial production, everything is done with machine precision, even in guinea pig production facilities. Guinea pigs are traditionally consumed as food, especially in some South American countries, and the process is carried out in large-scale facilities with a surprising system.